asked you to start the warm up. Hopefully you at least read it, maybe gave it a shot. I will help you with maybe the first couple so that you can get a good momentum going. Trying to see where I left my little tablet. Hang on. Okay, so you were asked how many solutions does each equation have? And it didn't necessarily ask for the solutions, but we might as well talk about them if you do know them. So as a class right now, how many solutions does number 1 have? Okay, 2, what are the 2 solutions? Okay, -3 and +3. So yes, this one does have 2 solutions. Remember, solutions are not what it's equal to. Like some people will say the solution is 9. Okay, no. Solution is the value for the variable that makes the statement true. So -3 squared is 9. 3 squared is 9. If you use the calculator and it told you that -3 squared is -9, that is not true. To make the calculator tell you the right answer, put that number in parentheses, then hit the square button. You should never square a number and get a negative, but that's a positive. Exponents tell you to multiply it by itself. A negative times a negative is always a positive. Questions on that? Okay. Now, again, together as a class, how many solutions does number 2 have? 1 solution. What is the 1 solution? 0. Earlier, someone said 0 and -0. 0 is technically not positive or negative. Okay, so if it says x squared equals 0, only 0 squared will give you 0. So that's why there's just 1 solution for that one. Okay, now you might have done that with guess and check, or you might have done that by like isolating the variable. Know that it's not always that easy to guess and check. Like as you can see, as you look on your paper and look at the other problems, it's not as easy to guess and check as maybe the first one. So do know that in each situation, you are isolating the variable, assuming that you're figuring out how many solutions are that way. There are other ways to figure it out too. But assume that you don't have graphing technology. To figure out what the solutions are, you have to solve algebraically, isolate the x, starting with what's farther or closest from the x. Friends, are we listening? Look at me when I talk to you. When you isolate a variable, do you start with what's closer or farther from the x? Farther. So when you're figuring out, should I get rid of this 2 or this 1 first? If you get rid of the 1 first, because it's physically farther, it would be easier to remove. How would I cancel out a -1? Good. Whatever you do on one side of the equal sign. Good, that's what keeps it equal. I get x squared equal to 3 plus 1, which is 4. Now that's probably easier to guess and check from there. How many solutions will this one have? 2 solutions. And what are they? Good. Now moving forward though, because if you didn't know that, keep isolating. What's opposite of squaring something? Square rooting. And whatever you do on one side, together. So that's what gets the exponent of 2 to cancel. And you can use your calculator to find the square root of 4. It'll probably just tell you 2. Moving forward, you need to know, especially for this unit, that anytime you square root something, you have the positive and the negative of that number. Okay, so plus or minus 2 is another big right. Anytime you square root, put a plus or minus. 0 can't necessarily be plus or minus, so I didn't put it there. But in all other situations, it's plus or minus whatever the number is. So now using that as kind of like, for some of you that had no clue what to do, use what we did in those first three to help you finish the rest of the warm-up. So there's 4, 5, 6, and 7 on your paper. I'll give you a couple minutes to try those out now. Table 6, for number 4, how many solutions do you have? 2 solutions. Did you figure out what they are? 5 and -5. So to get you guys in the habit of the plus or minus symbol, because we'll be using that this unit, if it happens to be the positive and negative version of the same number, I'm going to write my answers like that. But yeah, +5 and -5. So to solve that, okay, so in this situation where the x is being multiplied by 2 and raised to the power of 2, which one is technically farther? Technically the multiplying by 2. The power of 2 is harder to separate. It's like attached to that number, tells you what to do with that number. So the multiplying is technically farther in this situation, even though they're both all up against the x. The multiplying by 2, we'd have to get rid of first. By dividing by 2, I get x squared equals 25. Opposite of squaring is square rooting. And now moving forward, anytime you square root, remember the plus or minus sign. Good there? 2 solutions. And yes, there's other ways, but know that like you won't always have graphing, so try not to use graphing in this unit. Maybe just to check your answer. All right, moving forward. Table 7. These hopefully look a bit familiar. Table 7, how many solutions does number 5 have? 1 solution. And what is that 1 solution? -1 is correct. So this is a bit different from where we isolated the variable in the first 4, because I can't just like get rid of everything and get x alone on one side. But if you notice, what form is this called? No, try again. Different. Standard is a form, but this is factor form. Good. So factors are things we multiply. And if I have 2 factors that give me a product of 0, what must one of those factors be? 2 numbers that multiply to give me 0. What must one of those numbers be? 0. So the way that you can solve these algebraically would be to set each factor equal to 0 and solve for what value of x would make that 0. They just happen to be the same exact parentheses. So just one answer for this one. What value of x would make this 0? What plus 1 equals 0? -1. Questions on that? And then same thing over here. -1 plus 1 equals 0. We don't write -1 and -1 in our answer. That's why I choose 1 solution. Questions, comments, concerns? Okay, table 8, number 6, how many solutions do I have? Okay, while table 8 thinks of that, let me ask the rest of you. We saw these in the last unit, but what did we call them in the last unit? Or like, where would I find this on the graph? This answer of -1. The x-axis. So solutions, we're calling them solutions right now because we're solving for them algebraically. But solutions are the same as x-intercepts. What else do we call our x-intercepts? Zeros. And then there's one more that I don't think I've told you yet. We also call them roots. So make a note of that somewhere. Solutions are the same thing as x-intercepts, as zeros, as roots. They use them all interchangeably. So if it asks you for any of those 4 words, they are all asking about the same thing. So yeah, if you had graphing on your test, you could just look at the x-intercepts. But I told you a bunch of times and I keep saying it, you might not have graphing. So that's why we're also solving them algebraically. So table 8 for number 6, what are my zeros? Does that make it easier if I undo that? How many zeros did I have? How many solutions? 1 solution. Okay, what do you think that 1 solution would be? That is one of the solutions, but there's actually 2 solutions for this one. Anyone know what the other one would be? 0. Good. That you knew from like remembering the pattern in unit 6. The zeros were always like opposite of these signs. And then if one of them was just x, then one of the zeros was 0. Here's how we think of it algebraically. This is multiplying to give me 0. If I multiply to get 0, one of those numbers must be 0. So I have set each factor equal to 0 and figure out what x would have to be to make it true. So that's where we get x equals 0. And then if we start solving this, that's where we get x equals 6. Okay, questions? Now, table 9, what about number 7? Do you know how many solutions to that one? Okay. If I remember correctly, it is 2 solutions, but I get that this one's a bit harder. Because is this one equal to 0? So you can't apply that rule where we said like, if it multiplies to give you 0, one of them must be 0. So does anyone know the solutions for this one? I don't think it's -1. I mean, I can check right now. I don't have it memorized. But think, like, if solutions are values of x that make it true, what could x be? Or think of other ways you could solve it. 3, I do believe, is one of them. 3 minus 1 is 2. 3 minus 1 is 2. 2 times 2 is 4. And then what is the other one? It is -1 for the other one. Because if I do -1 minus 1, that would give me a -2. -2 times -2 is +4. So these are my 2 solutions. I don't have a good way of isolating it right now, solving it algebraically, because I haven't taught you like the other way yet. So I'm not going to throw that at you right now. But if you graph this, you would see straight lines. You wouldn't see the U shape. And I'm sure some of you figured this out like early on in the school year. That if you type it into Desmos, the equation, it'll put a line like where the X value is, but that doesn't mean you just like don't have to learn algebra. Right? But it gives you lines where the answers are. So use this as a way to check your answers if you have access to it, but you'll see why it's those later on. Questions on this setup? Okay, so today you'll notice like the note sheet is pretty straightforward. You don't see a whole lot of word problems today. Hopefully that's a good change for once. But today's a combo lesson and it is a bit of review. That's why we're combining them. Unit 6 was quadratics as well, just maybe like different things about the quadratics. So today we're finding solutions, which is the same thing as x-intercepts, which is the same thing as zeros. So you need to be able to find solutions by reasoning. So that would be like guess and check, kind of like what we just did. You need to know that quadratic equations may have two solutions. So look at all the problems in our warm-up. Are these all quadratic? Yes, they all are. What's the requirement for it to be quadratic? It has to have an x squared. You can clearly see the x squared in the first four. It's not hiding from you. These ones, which are all in factored form, if I were to distribute and multiply them out, I would get the x squared. So these are all quadratic. Did we ever have more than two solutions for our warm-up? All right, the most solutions you can have for a quadratic is 2. You can sometimes have one solution. You can sometimes have 0 solutions, although you haven't seen that yet. But the most you could have is 2 for a quadratic function. So that's one of the learning targets already checked off for today. We will talk about the zero product property and how to find solutions if one side is factors and the other side is zeros. So I'm recording right now, just like always, feel free to keep up if you're ever absent. And there's really no like time for procrastination anymore. We're at the end of the semester. So you gotta like keep up, you gotta watch the videos, you gotta take your own notes so that you can make this last unit test a really good score. Puzzle piece today will be lesson 3 and 4 combined, like it's not 2 separate ones today, just one. I will probably stop reminding you about this. I've talked about it a lot. If you lost points and the ACT is fire stuff and want those points back, do this extra credit. And I mentioned this already, the testing dates. You'll probably have 1 or 2 quizzes. I'll let you know when they are. I never stress about quizzes. I hope you don't have to either. I hope you just have notes and that you're ready every day. But these other grades are big grades. So make sure that, again, you're not procrastinating. We do have Saturday Academy. If you look at the back, like we're 420, 54, and 511. If you are failing around that time, expect an invite from me. Because I need to have on my record that I did everything I could do to make you pass. You got to do your end of it, which will be like doing corrections, retaking the tests. And we already did retakes in class, so now it's come to tutoring, go to Saturday Academy. Summer school is not free. I also don't know if it's really that effective because it's online. So keep that in mind. What else? Yeah, so if you're failing, expect an invite from me, whether you come or not. I'm not gonna beg you to pass the class. I feel like I've done everything I can. Moving on. All right, a little bit more algebraic solving. Be able to find these answers without graphing. Sure, if you have any remaining time and you want to check with graphing, by all means. But I should see you isolating the variable in each situation, and you telling me what the value of n is, how many solutions. Give you 4 minutes for the 4 problems. Collaborate, divide, and conquer. We'll go over it in 4 minutes. But Josh, can you tell me what the solutions are for number 1? Okay, let's see. So, I mean, and you could guess and check, but I think this way will be more effective moving forward. Isolate the variable starting with what's farther. Would that be the 2 or the 4? What's physically farther from the end, that, and that's enough. And how do I cancel adding 4? Whatever you do on one side. Good. So I get n squared equals 400. So I don't think it's gonna be. All right, because -4 squared is 16, 400 squared is not 400. So from this point, opposite of squaring something would be to whatever you do on one side. So there are 2 solutions. What are the 2 solutions? Good. And since it's like the same number, there's opposite signs, I'm gonna write my answer like that. But yes, it's positive 20 and negative 20 that make the equation 13. All right, table 9. What about number 2? What are my 2 solutions? Okay. So now let's see that. This time we're isolating n, it's on the right side, but same steps. Do I get rid of the 3 first or the 2 first? And opposite of multiplying 3 is whatever you do on one side. And 432 divided by 3 is, I don't expect you to know that in your head, but I remember it because I already did it once today. 144. Equal to n squared, n is still not alone, opposite of squaring is. And moving forward, don't forget that anytime you square root, you have the positive and the negative of that square root. Good, making sense? So then table 1, what are my 2 solutions for number 3? Okay, so let's see. This time in number 3, what's farther from the end? The exponent of 2 or the 1? Farther. The 2. And you always get rid of what's farther. Another way to think about it is order of operations in reverse. Like you'd have to get rid of the exponent before you go to the grouping symbol. Okay, but opposite of squaring is, so I'm going to do that on each side. Remember, this is a positive or negative anytime you square root, and it's 12. We just did that one over here. That gets rid of the exponent of 2, and there's nothing else surrounding the parentheses, so the parentheses can technically go away too. What's opposite of adding 1? Subtracting 1. Now, don't forget, because you have the plus or minus 12, you need to do positive 12 minus 1, which is what? 11, and negative 12 minus 1, which is negative 13. Okay. These 2 are my solutions. If you need to write it out so that you remember, or sorry, 12 minus 1. Then by all means, but this is what we did. We did the plus 12, the negative 12, minus 1. Table 2, what are my two solutions for number 4? -5 and +15. More stuff involved. What do we get rid of first? What is farthest from the end? The 30. Instead of subtracting 30 to cancel it, we would whatever, you know, one side of the equal sign. And this cancels. I get n-5 in parentheses squared equals 70 plus 30, which is 5. Now what's farther from the end, the 2 or the 5? Opposite of squaring is whatever, you know, one side. So we cancel out the exponent of 2 that way. We get n-5 equals square root of 100. Plus or minus 10. All right, and I don't expect you all to know your square roots. You can press a little button in your calculator and see. But then don't forget, it's plus or minus now. So what's opposite of minusing 5? Good, I hope I didn't lose everyone. And we get a +10 plus 5, which is, and a -10 plus 5, which is -5. Okay, that's where we get the two solutions from, because of that square root. Questions, comments, concerns? Good skills. Need that moving forward, how to isolate variables. Now, on the back, you have room to write down this definition. The zero product property, which says that if the product of two numbers is 0, then one of the numbers must be 0. We've talked about it a lot already. We've used it. You just maybe didn't know it had a name. It's the zero product property. So if the product of two numbers is 0, then one of the numbers must be 0. That helped us even answer a few of our warm-up, so we're gonna practice with this next set of problems. So in the next set of problems, notice that they're all equal to 0. And remember, solutions are values of x that make it true. So for that problem, think, what does x have to be to make that equation true? I'll give you a few minutes by yourself, like maybe 5 minutes. Some of them are actually really easy, like you don't need a whole minute per problem. And then we'll discuss after that, right? Yes, and then for number 1, what does x have to be to make it true? Oh, you're not table 4, but it's okay, I'll take it. Is there any other value of x that could make that true? Anything else -3 make it 0? So how many solutions for number 1? Okay, good. Notice this was not like a multiplication problem, so that's why there's just one solution. 3 minus 3 gives me 0. Now table 4, what does x have to be in number 2 to make it 0? -11. Are there any other numbers that can make it true? So just one solution for that one. And I'm not necessarily showing me isolating the variable. Hopefully, if that was troublesome for you, the guess and check part of that, just do the same thing we've been doing. Use your inverse operations, undo what's being done, isolate the variables. So good. Table 6. 2x plus 11 equals 0. What value of x makes that true? If it's 2 solutions, what do you think those 2 solutions are? Okay, so let's see. I agree with you that it's one solution. And I think, did you say 5.5 or negative 5.5? 5.5. Okay. So isolate the variable, start with what's farther. In this situation, we'd have to subtract 11 from each side first. I get 2x equals negative 11. Opposite of multiplying 2 is dividing 2, whatever you do to one side. And that is where we're getting 5.5, but it is a negative 5.5. Or negative 11 halves, you can leave it like that too. But just make this a negative 5.5. And it is just one solution. Nothing else will make that true. Okay, so table 7, what about number 4? Just 0, or is there another solution? Okay. Class, how many solutions for this one? 2 solutions. 0 is one of them. What's the other one? Negative 5.5. So here's where we are actually applying the zero product property. We have the product of 2 factors equals 0. So that means one of them must be 0. Now, instead of just like reasoning, guessing and checking, this might be more effective to figure out what x has to be to make it 0, because it could be either factor. Set each factor equal to 0 and solve for x. In this one, x is already isolated, so that's where we get the 0 from. In this one, we actually just did this problem in number 3. There's the algebra for it. X would have to be negative 5.5 to make this parenthesis 0. 0 times negative 5.5 would be 0. That's why there's 2 solutions. So notice, would number 4 be considered quadratic? Does it have an x squared? Maybe not in the form that it's in right now, but if I distributed, it would be an x squared. It would be x times 2x is 2x squared, x times 11 is 11x. Since number 4 is quadratic, you can expect that most of the time there will be 2 solutions. Not all the time, but most of the time 2 solutions. And all these other ones, 1, 2, and 3, are these quadratic? Do they have an x squared in them? No, and there's no multiplying I can do to get one, like in this one. Do you know what these are? They're not quadratic, they are linear is what I'm looking for, but yeah, these are all linear. These are all like y equals mx plus b. For linear, definitely just one solution. For quadratic, it's usually 2, can be less. So then look at number 5. Where am I? Who's next? 8, I think. So looking at number 5 from the set, what are my solutions for this one? What value of x would make it true? 3 and negative 11 is correct. You might remember doing this process in unit 6, but we called them zeros. And we didn't really know why they were the zeros. We just knew it followed like a pattern. of them being opposites of what was it. All right, but really, you're figuring out what x has to be to make this parentheses 0. Since we know that anything that multiplies to give 0, one of them must be 0. So that's where we get the x equals 3 and the x equals -1. Is that quadratic? Would it have an x squared if or would it be u shaped? Okay, we'll revisit that in a little bit, but 2 solutions, these are the 2 solutions. Table 9, what about in number 6? Okay, I think I heard you. Could you say one more time? 3 and -5.5 is correct. So set each factor equal to 0. These are factors. We're multiplying together. This would have to be 3. This we did earlier. We solved it algebraically. Remember, go back to look up on the paper. We figured that it would have to equal -5. So 2 solutions for this one. The last one, table 1. What are my solutions for number 7? Yep. 1.
That's all.
Okay. Anyone else at the table? So the -3 comes from this parentheses. And I can't really squeeze it in there, so I'll write it up here. X plus 3 equals 0. To make that 0, it has to be -3, right, for the x. What would this have to be to make it 0? 5. 0, so that's one of my answers. But then look over here, we have another factor. We have 3 factors in this one. We set each factor equal to 0 if they all multiply to give you 0. Solve them all separately to figure out what it has to be. So 2-step equation. You're gonna add 4 to each side. Instead of multiplying 3, you are going to divide 3 on each side. So this one has 3 solutions. And it's these 3. So is number 7 quadratic? No, because it has more than 2 solutions, but that's not really like, that tells us for sure it's not quadratic. Really, it's the x squared that makes it quadratic. So if I multiplied out 5 and 6, like FOIL, distribute, whatever you want to call it, I would get an x squared. If I multiplied this out, I'd actually get an x cubed, and that's no longer quadratic, okay? But that's how you solve it with the 0 product property. Good, question, comments, concerns? Okay, we only have 4 minutes left, but I still encourage you to like not just sit there and wait for the bell to ring. Make sure your notes like that you don't lose them, that you save them for the binder test. You could probably knock out quite a few problems on your practice, because they look just like this. So consider doing it while it's still fresh in your brain. Or watch the video and get a refresh.